In this lesson, we're looking at another way of solving quadratic equations. We're using the quadratic formula. You've seen this formula before, you learned it in Algebra 1, but if you don't have it memorized, no worries, it's on your reference sheet. All right, so x equals the opposite of -4 plus or minus the square root of -4 squared minus 4 times 3 times -9. Then we put that all over 2 times 3. Because remember that this is A, B, and C. So we simplify. We've got +4 plus or minus the square root of 16 plus, notice that it's plus because we have a negative times a negative, 108. And that's all over 6, which simplifies to 4 plus or minus the square root of 124 over 6. Well, we can simplify the radical because 124 is divisible by 4. So this would then become 4 plus or minus radical 4 times radical 31 all over 6. Well, the square root of 4 is 2, and then this fraction reduces to 2 plus or minus radical 31 over 6. I'm sorry, oopsie, over 3. Part B, we're using the same formula. So x equals the opposite of -9 plus or minus the square root of -9 squared minus 4 times 1 times 27. And that is all over 2 times 1. Simplifying, we have 9 plus or minus the square root of 81 minus 108 all over 2. 81 minus 108 is -27. So 9 plus or minus radical -27 over 2. And this negative sign tells us that our answer is going to have I in it. Also, 27 can be simplified since it's divisible by 9, which is a perfect square. So 9 plus or minus I times radical 9 times radical 3 over 2. Finally, our answer is 9 plus or minus 3I radical 3 over 2. So it's just a formula. In example 2, they're asking us to solve the equation using 2 different methods. And then it's asking which one you prefer. Myself personally, I like factoring because I like puzzles, but if that's not you, then that's understandable. So I'm going to solve this equation first by factoring. That means I'm multiplying 6 times 20. I get 120, and I'm looking for factors of 120 that will subtract to give me 7. And I think it's 15 and 8. Yes. So remember that I've shown you, put the 6x in both parentheses, and then the 15 and 8, and this sign of my middle term will go to my larger factor, so I want the 15 to be negative and the 8 to be positive. By putting the 6 in both parentheses, I've multiplied the expression by 6. Now I need to divide that away, and I'm going to do this one by 3 and this one by 2. So that simplifies to 2x minus 5 times 3x plus 4 equals 0. And then when I set each one separately equal to 0, I get x equals 5 halves, or x equals negative 4 thirds. I can also solve this equation by using the quadratic formula. X equals the opposite of negative 7 plus or minus the square root of negative 7 squared minus 4 times 6 times negative 20 all over 2 times 6, which will become positive 7 plus or minus the square root of 49 plus, because I have a negative times a negative, 24 times 20 is 480, all of that over 12. And then 49 plus 480 is 529. Which is a perfect square. The square root of 529 is, so 7 plus or minus 23 over 12. Then we simplify further. 7 plus 23 is 30 over 12 reduces to 5 halves, and then 7 minus 23 is negative 16 over 12, and that reduces to the negative 4 thirds. So as you can see, we end up with the same solutions regardless of which method we use. Just one might be easier depending on how your brain is. Now we're looking at the significance of the radicand in the quadratic formula. So that expression is called the discriminant, and if we evaluate the b squared minus 4ac, we can determine what kind of solutions we'll have just based on whether it's greater than 0, equal to 0, or less than 0. So here we're going to evaluate b squared minus 4ac. That means 8 squared minus 4 times 16 times 1, which is 64 minus 64. Oh, well, that is 0, which means that it will have one real solution. In part B, when we evaluate our radicand, we have negative 5 squared minus 4 times 2 times 6, which is 25 minus 48. And the actual value isn't important to us. What is important to us is that this is going to be negative or less than 0, which means that we will have two complex solutions. In this example, we're being asked if the height of the ball will ever be 4 meters, and the height of the ball is modeled by this quadratic equation. So what we're being asked is if the solution to negative 5t squared plus 5t plus 2 equal to 4, we're being asked if this solution is real. So all we need to evaluate is the discriminant. Remember, b squared minus 4ac. So, but my equation isn't in standard form yet, so I need to move the 4 over. So subtract 4 from both sides, and I have negative 5t squared plus 5t minus 2 equals 0. Now I have 5 squared minus 4 times negative 5 times negative 2 as my discriminant. This gives me 25 minus 40, which, because it's less than 0, tells me that the answer to the question is no, the height of the ball will never reach 4 meters. Finally, in example 5, we're going to use the discriminant to make our equation have a particular kind or kinds of solutions. So in example 5, we want to find a value of b that will make the equation have one real solution. So that means that we want the discriminant, b squared minus 4ac, to equal 0. So when we plug in the values from this equation, we have b squared minus 4 times 2 times 18. This equation simplifies to b squared minus 144 equals 0. So b squared would equal 144, and b is positive or negative 12. In this other example 5, it's the Triad problem from the textbook, it wants us to find a value of b so that there are two non-real solutions. That means we want our discriminant to be less than 0. So b squared minus 4 times 5 times 5 needs to be less than 0. Simplifying, we have b squared minus 100. Yucks, that's messy. Is less than 0. So if b squared is less than 100, then b would have to be between 10 and negative 10.